Morning to everyone who's attending this test discussion online. So I believe this is the first test, which is mostly geography, apart from few questions from current affairs, and I believe there are about 2 or 3 questions from polity as well. Okay, so we have the first question here. The first question says, consider the following statements with respect to water vapor. And below here it says, which of the above are not correct? Which of the above are not correct? Now, the first statement says, water vapor depends on temperature and it increases from equator to poleward and decreases upward from sea level. Now, you must understand that water vapor, that is nothing but a gaseous state of H2O, is an important component of the atmosphere. Is an important component of the atmosphere and is very, very important because it plays a very vital role in your water cycle. It plays a very important role in your water cycle. So if you have water vapor in the atmosphere, where is this water vapor coming from? The water vapor is coming from evaporation. It is evaporation of surface water. So water in the liquid state is present on the ground. It evaporates into water vapor, goes up into the atmosphere and comes down in the form of rainfall. Now, I'm pretty sure everybody understands the simple concept of evaporation over here. Correct? So higher the temperature or lower the pressure, evaporation rate increases. Evaporation rate increases. So if you take the earth, this is your equator, and within the tropical region, that is between the Tropic of Cancer and the Tropic of Capricorn, you have maximum insolation. You have maximum insolation. Therefore, maximum heat is received within the tropical region. If maximum heat is received within the tropical region, maximum evaporation takes place within the tropical region and not at higher altitudes. So if more evaporation, if more heat is received in the tropical region, more evaporation takes place in the tropical region, then more water vapor is present in the atmosphere in the tropical region and not at higher latitudes. Not at higher latitudes. So if the statement says water vapor depends on temperature, of course it does. So this is correct. Water vapor does depend on temperature. And it increases from equator to poleward? No. This is wrong. It is not increases, rather it decreases. Not increases, rather it decreases from equator to poleward. So this is incorrect. And decreases upward from sea level, this is correct. It does decrease from ground level and as you move up to greater altitude in the atmosphere. Why? Because more evaporation takes place at the surface level. Obviously, since evaporation is taking place, water vapor concentration is more closer to the surface of the earth rather than at an altitude. Please remember, about 80 to 90% of the water vapor is only present within the troposphere. 80 to 90% of the water vapor is only present in the troposphere, and this water vapor is responsible for your climate. Imagine a world where you did not have any water vapor, no water vapor in the troposphere. If there was no water vapor in the troposphere, there would have been no concept of weather or climate. The world would have been always hot and dry. This rainfall, fog, cyclone, cold, heat, nothing would have been there. Okay, it would have been rather a hot world, hot, dry world. This concept of climate would not have been there. Therefore, the first statement is incorrect. The second statement says water vapor is climatically important as it is both a greenhouse gas and an ozone depleting gas. Now, water vapor is climatically important. Of course, I just explained as to why is water vapor important with respect to climate, because it is the reason for the existence of this phenomenon known as climate. As it is both a greenhouse gas and an ozone depleting gas, water vapor is a very important greenhouse gas. Okay, so water vapor, just like methane, carbon dioxide, is able to trap heat and is responsible for warming of the earth. Rather, water vapor is responsible for trapping maximum heat. If there's a question as to which greenhouse gas is responsible for trapping maximum heat, it is water vapor. Why? Because not because water vapor is the most potent. One molecule of methane can obviously trap more heat than one molecule of water vapor. But the concentration of water vapor in the atmosphere is so much, the concentration of water vapor in the atmosphere is so high when compared to all other greenhouse gases that water vapor is responsible for maximum heat retention within the earth. Therefore, it is a greenhouse gas. But it is not an ozone depleting gas. This is incorrect. It is not an ozone depleting gas. Okay, so this particular statement is also incorrect. The third statement says water vapor is transparent for incoming long wave radiation, but not so transparent for outgoing short wave radiation. But it is not transparent for outgoing short wave radiation. Now, here I want you to understand something. Where do we receive radiation from? We receive radiation from the sun. Therefore, we'll call it solar radiation. We'll call it solar radiation. Now, whenever you consider electromagnetic radiation, the electromagnetic radiation can be radio waves, infrared rays, or microwaves, infrared rays, visible light, ultraviolet light, X-rays, and gamma rays. Now, the incoming solar radiation, that is radiation from the sun that we receive here on Earth, is mostly, more than half of the radiation that we receive here on Earth is visible light. Okay, so please remember, more than half of the solar radiation that we receive here on Earth is nothing but visible light. Is nothing but visible light. But when we receive this solar radiation on the surface of Earth, this solar radiation is also reflected back into the space. But when this solar radiation is reflected back to space from the surface, we call it as terrestrial radiation. We call it as terrestrial radiation. Now, there's a small change. The solar radiation that we receive, maximum it is visible light. But when the ground or the surface is going to reflect back these solar radiations, we are going to call it terrestrial radiation. These terrestrial radiation will not have the same wavelength as that of visible light. Rather, this is going to have a longer wavelength, and the terrestrial radiation will be nothing but your infrared rays. It is going to be your infrared rays. So what I'm trying to tell you is that solar radiation is incoming radiation, that is visible light, short wavelength. Short wavelength. Whereas outgoing radiation is known as terrestrial radiation, and this is infrared rays of longer wavelength. Of longer wavelength. Meaning what? Incoming is shorter, outgoing is longer. Now, if you understand the concept of global warming or greenhouse effect, I'm pretty sure you know it already, that when we receive the solar radiation, it passes through the atmosphere. When we receive solar radiation, it passes through the atmosphere and reaches the Earth's surface. But when it is reflected back from the Earth's surface, it is trapped by the atmosphere. It is trapped by the atmosphere. It is reflected back and it is trapped by the atmosphere. This is your greenhouse effect. Okay. So what is happening? Water vapor is transparent for incoming long wave radiation. No, incoming is short, but not so transparent for long wave radiation. Okay. So they have interchanged it. It should have been water vapor is transparent for shortwave radiation that is incoming from the sun, but when it is reflected back in the form of infrared radiations, that is long wavelength, it is not transparent. The reason being that the size of the molecules of water vapor resonates with the wavelength of infrared radiation, and therefore it prevents it from escaping. So all the three statements are incorrect. So if the question is asking which of the above are not correct, 1 is not correct, 2 is not correct, and 3 is not correct. And 3 is not correct. Next question. Consider the following statements with respect to the stratosphere. Now, stratosphere is an atmospheric layer. So if you have the Earth's surface here, the first layer is your troposphere, then comes your stratosphere. After that, you have your mesosphere, and then you have your thermosphere, and finally you have the exosphere. Earth, troposphere, stratosphere, mesosphere, thermosphere, exosphere. The ionosphere comes within the thermosphere. And the ozone layer comes within the stratosphere. Now consider the following statements with respect to stratosphere. What does the first statement say? Temperature increases with increasing height in this layer. If this is the Earth's surface, and this is the troposphere, I'll just draw the stratosphere now. This is the stratosphere. Okay. Now we have something known as the lapse rate. The lapse rate for the atmosphere within the troposphere is 1 degree Celsius for every 165 meters. Meaning what? As you go up into the atmosphere, for every 165 meters, the temperature would reduce by 1 degree Celsius. So this I am saying only with respect to the troposphere. So within the troposphere, the lapse rate is 1 degree Celsius per 165 meters. Okay. The reason being that if you consider the atmosphere, okay, the atmosphere is heated by the ground through conduction. So what happens if this is the Earth's surface? We receive the solar radiation. Okay, so the Earth's surface is heated up by radiation. The Earth's surface will heat the layers of air, that is atmosphere, just above it. If this is the Earth's surface, it will heat the layers of air just above it through conduction. Now, since air is fluid, this energy, heat energy, is mixed within the atmosphere or within the air through convection. Now, what happens is that since the source of heat is the ground, the layer of air closest to the ground is hottest. Just imagine that you have a beaker and you are heating it. Since the source of heat is at the bottom, obviously the layers of water will be hottest here. This will rise up and will result in exchange of energy through convection. But since the source of heat is at the ground, the layers of air is hottest at the ground. And as you move up in the troposphere with altitude, temperature reduces. So I would say that if this is a graph like this, temperature reduces in the troposphere with altitude until it reaches the tropopause. Beyond the tropopause is your stratosphere, and in the stratosphere we have temperature inversion. So if you know the concept of temperature inversion is nothing but the reversal of your lapse rate. Meaning what? Rather than the temperature reducing with altitude, the temperature increases with altitude. Rather than a temperature reducing with altitude, it increases with altitude. So then the question is why? The reason temperature increases with altitude within the troposphere is because we have ozone layer. We have ozone layer. So within the stratosphere, there is continuous breakdown of ozone to oxygen molecule and nascent oxygen, and then once again combination of oxygen and nascent oxygen to give ozone in the presence of sunlight. In the presence of sunlight, this process releases energy. Therefore, in the stratosphere, temperature increases with altitude rather than decreasing. Temperature decreases with altitude in the troposphere, whereas temperature increases with increasing height in the stratosphere. Okay, so the first statement is correct. The second statement says the stratosphere is devoid of any weather phenomena as there is no circulation of winds. Now, of course, I've already told you in the previous question, climate or weather is due to water vapor. Water vapor is present only in the troposphere. Therefore, you do not have any climate or weather pattern change in the stratosphere, exosphere, thermosphere, absolutely no. It is only restricted to troposphere. Therefore, stratosphere is devoid of any weather phenomena. Yes, because there is no water vapor. On top of that, there is no circulation of winds either. Now, the reason it is known as stratosphere is because the stratosphere consists of stratified layers. The stratosphere consists of layers where each layer with altitude increases in temperature. So the lowest layer of air is cooler, the layer above it is warmer, above it is even more warmer. And since the coolest layer is at the bottom, you don't have any mixture of air, you don't have any circulation of air either, you don't have air moving or wind within the stratosphere. Okay. Next, unlike the troposphere, this layer is not much important. So there is no circulation of winds in the stratosphere, but that does not mean that there is absolutely no circulation of winds. Okay, there is some amount of circulation of winds, and stratosphere is devoid of weather phenomena because of no presence of water vapor. So this statement is incorrect. This statement is incorrect. Third statement, unlike the troposphere, this layer is not much important for life forms in the biosphere ecosystem. This is wrong. Why? We have the ozone layer. You know it, I know it, the ozone layer protects us from harmful ultraviolet radiations. Therefore, option 3 is also incorrect, and therefore it is option 1. So, which of the above statements are correct? A, 1 only. 1. Third question, which of the following factors affect the distribution of insolation? Now, what do you understand by insolation? Insolation means the solar radiation that is received by us on Earth. Insolation refers to the solar radiation that is received by us on Earth. I've already told you it is mostly nothing but your visible light radiation. Okay. Now, which of the following factors affects the distribution of insolation? So the first statement is altitude. Does altitude determine the amount of insolation that we receive? No. With altitude, temperature drops. At hill stations, it is cooler. Why is it cooler? Because of the lapse rate. With increase in altitude, the temperature drops. And it is not because we have reduced incoming solar radiation with increasing altitude. So altitude does not determine the distribution of insolation. So this is incorrect. How about length of day? Does length of day affect the distribution of insolation? Of course it does. During summertime, the days are longer, which means what? Increased daytime, increased sunlight receiving time. Therefore, the amount of insolation that is received during summertime is increased. Whereas during winter time, the days are shorter, the night is longer. Therefore, the amount of insolation that we receive is reduced. Hence, what do we say? Length of day does affect or does determine the distribution of insolation. So this statement is correct. Third, we have sunspots. Now, I wouldn't say that sunspots do have a dramatic or drastic effect on the distribution of insolation on the Earth's surface. But if at all a statement is given or an option is given, then you may consider sunspots. What are sunspots? Sunspots are nothing but those areas or regions on the sun's surface where the temperature is much cooler when compared to other regions on the sun. So if this is the sun, I might have some areas along the surface of the sun where the temperature is cooler when compared to the surrounding region of the sun. Okay, so this is a region of more electromagnetic activity, and this disrupts the normal temperature and radiation that is emanated from the sun. Therefore, this may slightly affect the distribution of insolation that is received by us on Earth. Therefore, option 3 is also correct. Finally, we have transparency of atmosphere. If it is very cloudy, or if it is highly polluted, or if you have a cyclone, or if you have a volcanic eruption and the sky is covered by dust particles and soot particles, it will cut off the sunlight. Therefore, transparency of the atmosphere also affects the amount of insolation that is received by us on Earth. Therefore, not altitude, only length of day, sunspots, and transparency of atmosphere affects insolation. Option D, 2, 3, and 4. It is option D over here, 2, 3, and 4. Fourth one. With reference to the heat budget of the Earth, consider the following statements. The surplus heat energy from tropics, let me first explain what is the heat budget of the Earth. Okay, what is heat budget of the Earth? What is the average temperature of Earth? Average temperature of the Earth is just about 15 degrees Celsius. Is just about 15 degrees Celsius. Now, you may be from Bangalore, or you may have come from elsewhere, or you may be residing outside Bangalore as well. Now, just consider India itself, or just consider Karnataka itself, you know that the temperature, the average, the room temperature, room temperature, the ambient temperature varies from place to place. North Karnataka is very hot when compared to South Karnataka. Similarly, if you go to Himalayan regions, it is much cooler. And if you go higher up in the latitudes towards Northern Europe, for example, it is very, very cold. Whereas along the equatorial region, it is much warmer. But the average temperature remains to be about 15 degrees Celsius. In Bangalore itself, it around reaches to 30 and 30 plus during summertime. During summertime, some days it does reach more than 30. But the average temperature of the Earth, I'm saying annual average temperature of the Earth is always 15 degrees Celsius. Now, what happens? We've discussed this already. There is Earth. We receive incoming solar radiation, and some of this heat is lost in the form of terrestrial radiation, which is reflected back to the space. So this incoming radiation and this outgoing radiation balances the heat of the Earth and maintains 15 degrees Celsius. So this balancing of heat within the Earth is known as budget of the Earth. And within the Earth itself, heat is transferred from the equatorial region towards the polar region, so that there is no region which is very, very cold or continuously remains frozen, and there is no region which is very, very hot and continues to remain very hot. Rather, an average is maintained. Okay. So the first statement, the surplus heat energy from tropics is redistributed towards the poles as tropics gets heated up and high latitudes remain permanently frozen. Yes, the surplus heat from the tropics moves towards the polar region, and this heat is carried by your ocean currents and by the atmosphere in the form of maybe your planetary winds, okay, and by the air. Okay, so heat is transferred to higher latitudes. The second statement says, if the incoming heat and the outgoing heat are not balanced, then Earth would be getting either gradually warmer or cooler. This is true. So first statement is true, second statement is also true based on what I have explained just now. Okay, so this heat balance is due to transfer of heat, distribution of heat within the Earth, and also loss of heat when compared to incoming solar radiation, which maintains the heat budget and average temperature about 15°C. Of course, today anthropogenic activities is disrupting this heat budget, but that's a different aspect. Okay. So which of the given above is or are correct? Both 1 and 2 are correct. Both 1 and 2 are correct. Okay. Fifth one, which of the following can influence temperature of a place? Which of the following can influence the temperature of a place? Now, the first statement says latitude and altitude of a place. Does temperature of a region depend upon the latitude? Of course it does. Equatorial region, you receive more sunlight, whereas if you go higher up in the latitudes, the amount of incoming solar radiation reduces. The sunlight which is received is also along an oblique, and hence it is much, much cooler. So higher latitudes always very cold, whereas lower latitudes it is much hotter and warmer. How about altitude of a place? Of course, hill stations are much cooler when compared to regions which are very close to the sea surface or even below the sea surface. Why? Once again, your normal lapse rate. Your normal lapse rate. With increasing altitude in the troposphere, temperature reduces. Therefore, latitude and altitude of a place do determine the temperature of a place. Second is nature of land and water. Now, you would have come across this concept known as continentality. Does continentality determine the temperature of a region? Of course it does. So, if you take any landmass, say this is the landmass, the most interior region, say the center of the landmass, will have extremes of temperature. It can be very hot during daytime or during summertime, and it can be very cold during nighttime or winter time. When compared to the peripheral region, which is close to water bodies, Why? Water bodies have a moderating effect on the climate of the landmass. Therefore, any region that is your coastal region, which is next to a water body, or even any region which is close to a very big lake or a water body, for example, will have a moderate climate, will have moderate temperatures, no extremities. This is because of the distribution of heat from land to sea and sea to land due to air carrying away heat or bringing in heat. Therefore, nature of land and water distribution also plays an important role in determining the temperature of that region. Finally, prevailing winds. Do the winds determine the temperature of a region? You would have heard of local winds known as Lu in northern India, very hot, dry, dusty winds, which suddenly increases the temperature, results in heat strokes, also death of many people and withering of crops. Does it determine or influence the temperature of the region? Of course it does. You would have heard of Mistral, a local wind along the European region, which brings in cold temperatures from higher latitudes towards the Mediterranean region. It once again results in cooling the Mediterranean region. Therefore, the prevailing winds also play an important role in influencing the temperature of a region. So all three play an important role in influencing the temperature of the region. Which of the following is correct? 1, 2, and 3. Now, question number 6 says, Which is the reason for differential heating of land and water? And choose the correct statement from the ones given. The first statement says specific heat of water is much greater than land. Now, first of all, in order to understand, sorry, in order to be able to answer this question, you must understand what is specific heat. What is specific heat? Specific heat is the amount of heat energy required or necessary to increase the temperature of a substance by 1 degree Celsius. Meaning, the amount of energy I need to raise the temperature by 1 degree Celsius. So if I say specific heat of water is more than that of land, what does it mean? It means I need more energy, I need more heat to increase the temperature of water by 1 degree Celsius when compared to land. Meaning I can heat up land much more quickly than water. The reason being that land is opaque. Land is opaque. So if land is opaque, all the incoming solar radiation on the surface of the land is concentrated only to the surface. Therefore, the surface heats up much quicker when compared to water. Now, water being transparent or even in some places translucent, the incoming solar radiation is able to penetrate into deeper layers of the earth, and therefore it has to heat up more volumes of water. On top of that, water is not stagnant, rather you have mixing of water, and due to mixing of hot and cold water, you will require more heat energy you'll require more energy from the incoming solar radiation to increase the temperature of water. That is why we say specific heat of water is greater than that of land. So the first statement is correct. Second statement says oceanic areas are generally clouded, and hence they receive less insolation than land surface. Now, oceanic areas, obviously, the rate of evaporation is higher. Wherever you have water, obviously, evaporation will be more. If the evaporation is more, you may have more clouds. Small water bodies, it doesn't matter much. But when it comes to big water bodies like seas and oceans, obviously, the rate of evaporation is very, very high, because of which you have cloud formation, and hence this cloud formation may cut down on the amount of solar radiation that is received by the water surface. Okay, so oceanic areas are generally clouded, and hence they receive less insolation than the land surface may also be correct. The third statement says reflection of incoming solar radiation from the oceanic water surface is less than from the land surface. Now, you would have heard of this concept, albedo effect. Albedo effect. What is albedo? Albedo means reflection of the incoming solar radiation. So anything which is light in color, say white color, for example, will reflect all of the sunlight. Whereas anything which is darker in color will absorb all that solar radiation. So if you take glaciers, ice sheets, for example, it has very high albedo effect, meaning what? It will reflect almost all of the solar radiation. Whereas any dark surface like your metal road over here, or a cement road, sorry, not cement road has higher albedo. Any darker surface like forests or metal road, for example, they absorb more sunlight or more solar radiation. So albedo effect or albedo value ranges from 0 to 1. Ranges from 0 to 1. And the albedo of Earth is how much? 0.3. Meaning what? The Earth reflects back 30% of the solar radiation that is received by us. Whereas 70% of that heat energy and the solar radiation is retained by the Earth. Now here the question is asking for what? Reflection of incoming solar radiation from oceanic water when compared to land surface. Please remember, the oceans absorb more solar radiation when compared to the land. The oceans absorb more solar radiation than when compared to land. The oceans are a bigger heat sink when compared to land. Therefore, land has higher albedo, whereas water, ocean surface, has lower albedo. So, reflection of incoming solar radiation from the oceanic surface is less than the land surface is correct. It is correct. Fourth option, opacity of land is high when compared to water. Opacity of land is obviously higher. I've already told you land is opaque whereas water is transparent. Therefore, this statement is also correct. So all these reasons actually determine differential heating of land and water. So which of the statements are correct with respect to differential heating of land and water? It is 1, 2, 3 and 4. So option D is correct. Option D is correct. Next question, question number 7. With respect to fogs, which of the following statements is or are correct? I'm pretty sure you understand what are fogs. Fog is nothing but cloud at ground level or surface level. Fog is nothing but cloud at surface level. Whenever you have air with high moisture content along with dust particles, and if the temperature drops, what will happen to all that moisture content? That water vapor will condense on these dust particles, forming tiny water droplets which are able to float just above the surface of the earth. This gives rise to fog. This gives rise to fog. So with respect to fogs, which of the statements are correct? First statement says, due to inversion of temperature in lower layers of atmosphere, dust particles along with fog formation result in a recent urban problem of smog. What is smog? Smog is nothing but fog plus smoke. Now, if you understand the concept of temperature inversion, what is temperature inversion? A reversal of normal lapse rate, where rather than temperature decreasing with altitude, temperature will increase with altitude. This is due to temperature inversion. So what will happen? You may have fog along the surface due to air being cooler close to the surface. If that region is also polluted, such as in urban areas, fog plus smoke will give rise to smog. So this is correct. First statement is correct. Second statement, due to occurrence of inversion in the morning of summer season in low latitudes, dense fogs are a common phenomenon. Now, this particular statement is very true. It is very correct, except for the fact that it is not summer season, rather it is winter season. Rather it is winter season. During winter time, when the sky is clear and the night is very cold, there is a lot of terrestrial radiation which is lost, which ensures that we have something known as your temperature inversion, which occurs during winter time and not during summertime. So the second statement is not correct. The second statement is not correct. The third statement says the inversion commonly lasts for few hours till the sun comes up in low latitudes. Now, this particular statement is correct. See, again, if you already know the concept of temperature inversion mostly occurs early morning. This is especially with respect to ground temperature inversion. So ground temperature inversion occurs early in the morning until the sun rises up and you have enough solar insolation which will heat up the earth's surface, which in turn will heat up the layers of air just above it, and therefore this temperature inversion dissipates and you have normal lapse rate. So the third statement is correct. Second is wrong. First and 3. 1 and 3. Question number 8 says assertion and reasoning. So out of considering the assertion and reason, you have to understand if the reason is the correct explanation for the assertion. So the assertion says ground inversion occurs in low latitude areas during winter nights. Of course, this is true. This is true. Okay, so during long winter nights, what happens? more long winter clear skies, there should not be enough, there should not be any clouds which may trap in the terrestrial radiation. So during winter night, when the sky is very clear, all the terrestrial radiation is lost out into the space. And therefore, you are able to see ground inversion. So assertion is correct. Reason, presence of dry air aids ground surface inversion. Yes. If ground surface, if presence of air, if the air is not dry, rather, if the air has a lot of water vapor, for example, this water vapor is nothing but a greenhouse gas, will not allow the terrestrial radiation to escape, rather will trap the terrestrial radiation and will ensure that the surface close to the atmosphere close to the Earth's surface is warmer. If the atmosphere close to the Earth's surface is warmer, you will not have ground inversion. Therefore, it is also necessary that the atmosphere is dry. That is why no clouds. Okay, so presence of dry air aids ground surface inversion. But this is not the explanation for it. Both are correct. Both are conditions necessary for ground temperature inversion, but this is not an explanation for this. Therefore, I would say it is both A and R are correct, but R is not the correct explanation for A. Ninth question. Volcanic eruptions cause which of the following? Now, I'm pretty sure everybody understands what are volcanic eruptions. Volcanic eruptions are nothing but opening along the Earth's surface where magma from within the Earth's, that is from the magma chamber, is able to reach the surface. Now, this volcanic eruption may cause many things. For example, mass extinction of species. So, volcanic eruption, a very massive volcanic eruption, is considered to be one of the reasons responsible for causing the extinction of dinosaurs. So one of the theories is that there was a very big volcanic eruption and this resulted in spewing dust particles, soot particles into the atmosphere, which cut off the sunlight for many, many years, which affected the vegetation growth on the Earth's surface. There was no sunlight which was received on the Earth's surface. Therefore, dinosaurs, vegetarian dinosaurs, herbivorous, my mistake, not vegetarian. Herbivorous dinosaurs did not have vegetation to feed on and also did not have sunlight for heating of their body. Carnivorous dinosaurs could not have feeded on herbivores because they also went extinct, and carnivorous dinosaurs also did not have enough sunlight to survive, because obviously reptiles depend upon the outside environment for regulating their body temperature. They don't have internal regulation of body temperature. So volcanic eruptions can result in mass extinction of species. The second statement says diversion of natural drainage systems. Obviously, you may have a volcanic eruption, the lava flow can dam a river flow and therefore change the natural drainage system. Killer acid rains. Whenever you have volcanic eruption, it spews many gases into the atmosphere. One such gas is sulfur dioxide. So all that sulfur dioxide which is released into the atmosphere will come down along with rain as weak sulfuric acid, resulting in acid rains. Statement 3 also correct. 4, alter radiation balance of the Earth. I've just explained this while explaining mass extinction of species. Dust and soot particles which are spewed into the atmosphere will cut off the sunlight, affects the heat balance of the Earth. This statement is also correct. So choose the correct options, all of the above. Question number 10. Now, question number 10 says the Earth is layered like an onion because of which process? So here it gives two processes, statement 1, statement 2, differentiation by density and differentiation by composition. Now, going back to your, early solar system formation, when the solar system was being formed and Earth was also being formed along with it, there were several changes which took place. One such change is known as differentiation. So what is this process of differentiation? So what happened was that when the solar system was being formed and the Earth was also being formed along with it, this Earth came to being by a process known as accretion. That is, many materials clumped together. They all clumped together while revolving around the sun. They all clumped together to form a big ball. But what happened? There was collision. Meteorites, rocks, asteroids, many big chunks came together and collided. There was no atmosphere. So the temperature was very, very high. Since the temperature was very, very high, metals like iron, nickel, they all melted and they moved towards the center of the earth. Therefore, if you look at the earth today, the center is made up of iron and nickel. It is very, very dense and is made up of heavier elements. Whereas towards the surface, if you see, it is made up of lighter elements like alumina or silica. So this process of classification, so at the core it is the densest and made up of iron and nickel, whereas if you start moving towards the surface, it is made up of different materials like silica and iron, which is much lighter. The density of earth is about around 5.5 grams per centimeter cube. The density of earth is about 5.5 grams per centimeter cube, whereas the density of the core is about 13 grams per centimeter cube, and that of the surface is about 2 grams per centimeter cube. Meaning what? There is differentiation of density. I also told you there is differentiation of composition. At the core, metals, iron, nickel. Along the surface, alumina and silica. Therefore, differentiation of composition. It is nothing but classification of substance across density and material, which gave rise to Earth and the different layers which make up your continental crust, oceanic crust, upper mantle, lower mantle, outer core, and inner core. So both statements 1 and 2 are correct. So correct.